The short answer, yeah, climate change is real, and we've got enough data now that this actually isn't contested in scientific circles anymore. But whether you should be losing sleep over it depends partly on how you interpret the evidence, and that's where things get complicated. Let's start with the is it real part, because that's settled. The planet has warmed about 1 to 1.2 degrees Celsius since the late 1800s, with most of that warming happening in the last 40 years. We're not talking about some abstract measurements. Here, the data comes from satellites, ground stations, ocean buoys, ice cores, tree rings, and basically every tool we've developed to measure temperature. In 2024, Earth hit a significant milestone. It became the first calendar year to exceed 1.55 degrees Celsius above pre-industrial temperatures. It's not a minor fluctuation. Multiple independent tracking organizations confirmed this. NASA, NOAA, Berkeley Earth, and others all arrived at the same conclusion. The warming pattern is also consistent across every major dataset we have, which matters because it rules out measurement error as an explanation. Here's what makes this undeniable. The underlying physics has been understood for over 150 years. Scientists figured out that carbon dioxide traps heat back in the late 1800s, and we've been systematically pumping more of it into the atmosphere ever since. In 2024, atmospheric CO2 reached the equivalent of 34 billion tons of CO2, trapping the energy equivalent of 8 Hiroshima bombs every second. That's not poetry, that's a physics-based calculation about energy accumulation in the atmosphere. The impacts of warming are becoming visibly real too. Sea levels have risen about 8 inches, or 20 centimeters, in the last century, but the rate is accelerating, now rising about 1 centimeter every 2 years, which is nearly double the rate from earlier decades. Glaciers are retreating globally, and ice sheets are losing massive amounts of ice. Greenland has lost an average of 279 billion tons of ice annually between 1993 and 2019, while Antarctica lost about 140 billion tons yearly. Swiss glaciers lost alone 10% of their volume in just 2 years. Arctic warming is happening nearly twice as fast as the global average. Sea ice is declining in both extent and thickness. Ocean acidification has increased about 30% since the Industrial Revolution, because the ocean has absorbed between 20% and 30% of human CO2 emissions. These changes aren't predictions, they're measurements we're taking right now. So, the overwhelming scientific consensus is that humans are causing this warming. Studies put it above 99%. Essentially, if you walked into a room of 100 climate scientists, less than one would disagree that humans are responsible for the current warming. That matters because it's not actually where the debate is happening anymore. When you look at what climate scientists publish in peer-reviewed journals, you're not finding them arguing about whether humans are responsible, you're finding them debating how much warming we'll get and which specific impacts will hit hardest in different regions. The IPCC, basically the gold standard for synthesizing climate research, confirmed in their 6th assessment report that the influence of human activity on the warming of the climate system has evolved from theory to established fact. That's a formal, global scientific consensus, not a speculation. Now, here's where I want to actually engage with the skeptical side, because pretending they have no points worth discussing is its own kind of dishonesty. The uncertainties in climate projections are genuinely significant. The IPCC estimates that doubling atmospheric CO2 could produce somewhere between 1.5 degrees Celsius and 4.5 degrees Celsius of warming. That's a threefold difference, and that matters for how you think about policy responses and urgency. Some of the common skeptical arguments fall apart pretty quickly, though. The idea that urban heat islands explain global warming gets ruled out because climate scientists account for that in their models. The argument that volcanoes emit more CO2 than humans doesn't hold, because human emissions are way higher. But there are more substantive critiques. Climate models sometimes struggle with reasonable predictions, even when they get global temperature trends just right. That's a real limitation that we should actually acknowledge. Now, there's also genuine uncertainty about feedback loops. As snow and ice melt, they reflect less sunlight back into space, which accelerates warming. Methane, over 80 times more potent than CO2 in its first 20 years, gets released as land heats, and it's building up in the atmosphere faster than we expected. Wildfires emit massive amounts of CO2, or approximately 33.9 billion tons in 2021. and produce black soot that accelerates glacier melt by landing on ice and reducing albedo. Warmer oceans release more water vapor, which acts as a greenhouse gas. The rainforest is becoming a net carbon emitter rather than a carbon sink. These positive feedback loops could make impacts worse and faster than models predict. Some of this uncertainty comes from how quickly things are changing. Current warming trends are happening at a rate not seen in the past 10,000 years, which means we're in a genuinely novel territory. The 2024 warming was driven partly by natural factors. A strong El Nino event combined with structural warming from greenhouse gases, and disentangling exactly how much each contributes is legitimately complicated. So here's what's interesting. Even researchers who take climate change seriously don't all agree on catastrophic level predictions. One analysis looking at the actual chain of causation from warming to civilizational collapse noted that while climate change appears less worrying than most, when you compare it to the other potential existential risks, the gap between warming and disaster requires a lot of things to go wrong in sequence. Feedback loops amplifying things, impacts overwhelming society's ability to adapt, that's somehow turning into military conflict, and then somehow causing systematic collapse. Now, none of that is impossible, but it's not automatically inevitable either. Humans are actually decent at adaptation when we see problems coming. We've already made renewable energy dramatically cheaper than it was a decade ago. We know what the mitigation strategies are. We're just not implementing them fast enough. But here's what's actually concerning: the timeline and the complexity. We're already committed to additional warming. Some scientists estimate that even with immediate emission cuts, warming of 0.5 degrees Celsius to 1 degree Celsius is already in the pipeline. 2024 essentially signaled that Earth has most probably already entered a 20-year period at 1.5 degrees Celsius warming, which means the climate impacts documented at that warming level will likely start to emerge within this decade. The health impacts are already being measured. We're seeing increased frequency of extreme heat events, which directly kills people and disrupts agricultural labor. Drought is affecting more land every year, well, by 30% increase annually recently. Diseases spread by mosquitoes are expanding their range. Mental health impacts from natural disasters are documented. Food supply chains are becoming increasingly fragile. The economic costs are staggering. Current estimates are $143 billion lost annually to extreme weather, with $38 trillion per year in losses predicted by mid-century, regardless of current emission choices. What makes me less concerned about doomsday scenarios isn't that climate change isn't serious, it's that the actual scientific picture sits somewhere more reasonable than the polls of the debate. The data suggests climate change is a serious, real measurable problem that requires significant action, but the catastrophism versus denialism polarization means we end up with this weird situation where you almost have to choose between ignoring the problem entirely or believing we're all doomed. That's largely because money's involved. Fossil fuel companies have incentive to downplay climate change. Environmental groups have incentive to emphasize catastrophe. That creates this polarized mess where reasonable people in the middle get squeezed out. But the scientific consensus doesn't need political agreement to be true. The warming is happening regardless of what we think about it. Should you actually worry? I would say yes, but rationally, you should worry the way you'd worry about an oncoming storm you can see on the horizon. It makes sense to prepare and adjust your plans, not because we're necessarily doomed, but because it's the rational response to a real threat. The thing that keeps this from being pure despair is that we actually know what to do. Rapid emission reductions, adaptation planning, investment in clean energy, agricultural transformation, changes to supply chain, none of it is impossible. It's just hard and slow when when it needs to be fast and large scale. The 2024 breakthrough of crossing 1.5 degrees Celsius isn't the time for despair. Researchers emphasize it's a call to action. That framing matters because it acknowledges urgency without demanding panic. We're in a situation where the window for preventing the worst outcomes is closing rapidly, but it hasn't closed, and that's not nothing. Thank you guys for watching this video. If you enjoyed this kind of video, and only if you enjoyed this kind of video, please leave a like and subscribe. I spend a very long time on these videos. Thank you for watching and have a good day.